In this lesson, we're going to be talking about how to solve systems of inequalities. So this slide is just a review of how do we graph an inequality. So a couple things we need to remember. If we have a dashed line, that means that we are either graphing a less than or greater than scenario. If we have a solid line, then we are graphing a less than or equal to or a greater than or equal to scenario. We also have to think about shading. So if it's greater than or equal to, we're going to shade above the line. Whereas if it's less than or equal to, we're going to shade below the line. Keep in mind that the equations need to be in slope-intercept form, so they need to be solved for y. So when we graph a system of inequalities, we are going to graph both inequalities on the same coordinate system. Then our goal is to figure out where on the graph do the shadings overlap. That overlapping shaded region will be the solution region to the system of inequalities. So we're not just going to have a single point like we had with a system of equations. We're going to have a whole region that represents the solution to the system of inequalities. All right, here's our first example that we're going to take a look at. The first inequality reads y is less than negative 1/2 x plus 3. So let's go ahead and graph that inequality on the coordinate system. So we see that we have a y-intercept at positive 3. And then to get to the next point, we're going to go down 1 and right 2. I'm going to continue to put some additional points on my graph so it'll make it easier to connect those points in a straight line. The next thing we have to think about is, should we connect these points with a solid line or a dashed line? This is when that inequality symbol comes into play. This is a less than scenario. So that means we do not want to include the points that are on the line. So we're going to make this a dashed line. And then we also have to think about shading. So less than, we shade below the line. So there is my first inequality graphed out. I'm going to graph the next inequality in a different color. I'll choose blue. Our y-intercept is at negative 1, and our slope is 2. So I'm going to rise 2 and run 1. Again, I'm going to continue to mark points so that it makes it easier to draw a straight line. And I can also move down 2 and to the left 1 instead. Again, we have to think about what type of line. This is a greater than scenario. So again, we do not want to include the points that are on the line. So it's going to be another dashed line. And for greater than, we shade above the line. So remember what we said in the last slide. We're looking for where do the shadings overlap. So I'm going to clean up my solution because I see where the red, or I guess that's pink, and blue lines are crisscrossing. That's going to be my solution region. So I need to get rid of the parts of the shading that are not overlapping. So anything that is only blue, I want to erase that part of the shading. And anything that's only pink. I'm going to erase that part of the shading. So what is left is just my solution region, which is again the overlapping shaded parts on this graph, which it's kind of like this whole triangular region. But notice that these lines are dashed. So I'm not including those dashed lines, but anything inside this overlapping shaded region would be my solution region. Okay, taking a look at the next example, we have two new equations. My first inequality, rather, is y is greater than 4x minus 3. So I have a y-intercept at negative 3, and I'm going to rise 4 and run 1 to get to my next point. Again, I'm going to continue to mark some dots just to make it easier to make a straight line using my finger. Okay. Thinking about the type of line, we have a greater than inequality symbol. We do not want to include the points that are on the line. So I'm going to connect these with a dashed line. And thinking about the shading, this is greater than, and so greater than we shade above. The next inequality, I'm going to go ahead and change color. So we have a y-intercept at positive 3, and we're going down 2 and right 1. I'm marking a couple of extra dots, again, to make it easier to make that straight line. I could also move up 2 and to the left 1. Okay, thinking about how I should connect those points, I see a greater than or equal to sign. So this time I do want to include the points that are on the line. So I'm going to connect with a solid line. And thinking about the shading, it's greater than or equal to, and we shade above. Thinking about that solution region being the overlapping shaded regions, I want to see where the red and the blue lines crisscross. I want to also get rid of anything that is shaded only in blue. And likewise, I would want to get rid of anything that's shaded in just red. Those are some big regions, so this might take me just a minute to get all of these single color shadings erased. So I've erased all the ones that are only in blue, and now I'm going to erase the ones that are only in red. With this particular example, we do have one dotted line and one solid line. So the solid line that is in red, we want to include the points that are on that line. But the dotted line that's in blue, we would not want to include those points as the solution region. We can get very, very close to them, but we actually don't want to be on that dotted blue line as part of the solution. So taking a look, this is, again, it looks kind of like a triangular region up here. This is my solution region. I'm including the points on the red line, but I am not including the points on the blue line because it's dashed. Taking a look at the next example, we have y is less than 3. I'm going to graph that in blue. So y is less than 3. We would have a horizontal line at a y value of 3. So I guess I could put some points on here that would be along that horizontal line. -5, 3, -2, 3, 0, 3, 2, 3, 5, 3, so on and so forth. So we can see that horizontal line that's forming. If I think about the type of line that I want. It's less than, so I'd have to make it a dashed line, meaning that we're not including the points on the line. And for less than, we would shade below. Switching colors, the y-intercept of the second equation or inequality is +1, and my slope is -1. So I'm going down 1 and right 1. Or I could move up 1 and left 1. Thinking about the type of line, we have the inequality less than or equal to. So I do want to include the points on the line. So I'm connecting in a solid line. And less than, we shade below. Taking a look at where the shadings overlap, that is going to be my solution region. So I'm going to get rid of any shading that is only red and anything that is only blue. So I'm looking for that overlapping region to represent the solution. Okay, so we see that this one, it kind of looks like a quadrilateral shaped region. That is my solution region. Okay, here's our next example. We have a y-intercept of +4, and we have a slope of -3/1. I'm going to connect those with a dotted line since it's a less than symbol. And I'm going to shade below. Changing colors, I'm going to plot the next inequality in red. We have a y-intercept of -1, and again, a slope of -3/1. If you notice, these two lines have the same slope. What that means is they are going to be parallel to each other. Connecting that with a dotted line because it's a greater than, and I'm going to shade above. Okay, this one it's a little bit more difficult to see the overlapping area because it's not very big. However, they are overlapping in that small little area between the two parallel lines. So again, if I clean this up a bit, I'm going to erase anything that's only shaded in red. So that is anything above that blue dotted line. And I'm also going to erase anything that's only blue, which the only blue shaded is anything below the red dotted line. I'm going to leave that shading that's between the two parallel lines because that is representing my overlapping shading, which is the solution area. So with parallel lines, we could have that skinny region in the middle between them to be the solution area. However, there's a special case that could happen with parallel lines, which we're going to see in the next example. Okay, I finally got all those erased. So this is my solution region. It's just that rectangular area between the two parallel lines. Okay, our last example for our notes today is very similar to the last example that we looked at. When we go to graph these, we see that they're the exact same two inequalities. So I have a y-intercept at +4 and a slope of -3. I'm going to connect this one with a solid line. And it's greater than, so I'm going to shade above. Okay, the second line, the second inequality, has a y-intercept of -1 and again a slope of -3. Hopefully we're noticing, oh, these are those same two parallel lines as before. This one is less than, so I'm going to connect with dotted lines that are supposed to be straight. Sorry about that. And this one is less than, so I'm going to shade below. Notice that there is no overlapping region. So this particular solution or this particular system has no solution. There is no points that are in the overlapping shaded region because there is no overlapping shaded region. Okay, this concludes our notes on solving systems of inequalities.